Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
For the longest time, space launch systems were single use. Everything was disposable and expensive. Now space launch systems are more and more all about reusability. SpaceX started the trend with its Falcon 9 rockets, and companies like Rocket Lab, Sierra Nevada, Orbital ATK, and others are all looking at reusability of at least some rocket components. Allied Market Research released a report last year indicating that the reusable launch vehicle market is estimated to be worth $1.38 billion in 2025 and grow to $3.56 billion by 2035. My guest on this edition of the Ex Terra Podcast is Kelly Henning, COO of Stoke Space, a company developing 100% reusable rockets designed to be flown daily. Kelly, thanks for joining me.
Thank you for having me.
It's my pleasure. Stoke Space is possibly the first real competitor to SpaceX's fully reusable rocket. So tell us about your fully reusable second stage that makes this possible.
Absolutely. One of the difficulties in reusing a second stage, as I'm sure you know, is having it survive atmospheric reentry. You've seen many different approaches to that in the past with either ablative heat shields or ceramic tiles. Those types of solutions limit the amount of reusability you can get out of it. Of course, the ablative heat shield is a one-time use, and then the ceramic tiles need to be inspected over and over again. They have very disastrous failure modes that can be, even tragic, and they need to just be constantly maintained and inspected. And in addition, when the stage actually will land, they're very hot. So it takes a while for you to actually approach them. And they have to develop novel ways of pulling them off in order to be able to reuse the rocket quickly again. Our approach is to use an actively cooled metallic heat shield that essentially, the failure mechanism is very passive. If you get a hit with a bird, or you drop a hammer on it, or any of those types of things, it just overcools in that particular area. We use hydrogen, which is our fuel for the second stage. It's cryogenic, and so it flows through the skin of that heat shield and keeps it cool enough to survive reentry.
How did you come up with that, or how did your engineers come up with that idea?
I didn't come up with it. I can tell you that right now. That was not me. Andy and Tom, who are the founders of the company, started the company during the pandemic. And I like to tell a story that they were in the basement and they said, how can we, using first principles, come up with an approach to reusability for the second stage, and how can we protect it? And their specialty is rocket engines, and they actively cool the combustion chambers using fuel all the time. And so they theorized that the thermal environment would actually be similar in the combustion chamber as it would be right on that surface of the shield during reentry. Not necessarily the temperature, but the heat flux would be similar. And so using the principles of cooling the combustion chamber with the fuel, cryogenic fuel, flowing through channels in the structure, they thought they could do the same thing with the heat shield.
Is it something that you can test without actually flying?
There's certain parts of it that you can test. We've tested it so it is part of the engine. So the cryogenic fuel will flow through the heat shield itself, and then to the combustion chamber, and then to the turbine. So it is part of the actual cycle for the engine. And so we have tested it when we're doing the engine tests. And so it's part of that overall, testing sequence. The actual heat and exact environment that it's going to experience during reentry, there's not really a way to test that exact scenario on Earth.
Now, your engine system and fuel system are also a bit different than the industry norms. What's different about them?
Our engine system and fuel system. Well, we are using hydrogen. And we are using an expander cycle. So the fuel, as it goes through the heat shield and the combustion chamber, picks up or expands and heats up, and then that powers the turbine, which then, turns the pump. And so before it's let off. So I don't believe there's another engine that is using that particular cycle right now. So in that case, it is very, very unique. And I don't necessarily believe that there's any hydrogen upper stages, or there's not too many hydrogen upper stages being used right now.
So you're developing a two-stage rocket.
Two stages.
Yeah, two-stage rocket. Now, what's the recoverability on the first stage? Is it like we see with SpaceX, or is it like we're going to see with Rocket Lab? How are you bringing that one back to be able to be used again very, very quickly?
We are bringing it back very similar to what SpaceX would do. So we have not fully developed the first stage. We're still in component testing and engine design, but we do intend to do something very similar to what SpaceX has demonstrated.
Kelly, how did you get into this? Tell us a little bit about your background.
Sure. Right out of graduate school, I joined old TRW, which was then taken over by Northrop, and I think it was in Redondo Beach, California. And I started working on advanced electronics for them. And so I was individual contributor, and then I moved on to more program management and chief engineer roles, and I did that for a number of years. And then I moved on to strategy and a number of roles in that area. After that, I moved to Raytheon, where I worked in their space payloads group, and then over into their Department 22, which is their advanced concepts and technologies group. And so I had leadership roles in both of those organizations. And then Stoke reached out to me and asked me to come on board and join them in this awesome adventure. And I was very, very excited.
So has space been something that you've been interested in for a long time?
I've been in space for a very long time. Yes, I would definitely say so. I've been interested in space since I was a little girl.
Most people that I talk to, and we talk about how they got into their roles, they can recall a specific incident that said, this is when I knew that I wanted to be in space. Do you have such a story?
Do I have a story? I don't know. I don't. I think I always did. I think it was something that, I was surrounded by. And so it was something that I always wanted to go into.
You've talked about this a little bit already, but give us a little bit more of the company's origin story.
Oh, sure. So Tom and Andy, the co-founders, they had worked at another company and done some pretty amazing work there. And they really wanted to focus on full reusability, and they wanted to go very, very fast. And so that was not something they were seeing in their current company. And so they decided to strike out on their own and try something new and form a brand new company to have a little bit more control and set the culture and the tone and really tackle this reusability problem.
When you talk about they wanted to go fast, and obviously development of products for space is almost never a fast proposition. So how are they approaching that to be able to bring something to market quickly?
They have adopted and they maintain a culture that is based on design, test, and iterate. And design, test, and iterate. And understanding that the most that they can actually learn about a design is not necessarily through full simulations, but really in doing the test itself. And so we have embedded that into the culture that, we will learn and we will keep going and keep trying again. And our test facility is only about 3 hours away from our design facility and manufacturing facility. So as we're testing and we need to do design changes to optimize the performance or get it working, we can make a change very, very, very quickly, have it manufactured, and then drive it out to our test location and do all of that within one day. And so you regularly see people on the Slack channels asking who's going to the test facility and who can bring over the parts and who is coming back and things like that. And so people are constantly ferrying hardware back and forth from the test location.
It seems that there's a new launch company popping up every 2 or 3 times a year. I get releases of companies that we're getting into the launch business. So how challenging is it to come into what's becoming a more and more crowded market?
It's challenging. I would say it hasn't, for a while there was a number of launch companies starting all the time, and you were getting wind of a new one. I think it has slowed down a bit. So I don't think you're seeing that same volume of entrants as we did a couple of years ago. But definitely there are a lot of people right now focusing on this space. The important thing is to make sure that you have a product that is differentiated. And so we believe that we have that. We have this fully reusable second stage. Ensure that you have the absolute best talent possible. And I think we have that. I think we have phenomenal people here who are experts in their field and have done amazing things. And then 3, have a culture that supports them, that can make them go fast, and that they have everything that they need, and that is unwavering. And then I guess 4th, hopefully I'm on 4. 4th is to stay focused and do not get distracted. Don't come up with anything that's gimmicky or something just to make yourself stand out. Be very, very sure of your thesis and stay focused on that.
I'm talking with Kelly Henning, COO of Stoke Space on the Ex Terra Podcast. Take a moment right now to click subscribe to make sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. So Kelly, where are you now in the development of your rocket, and what kind of timeline are you looking at for the first commercial launches?
We have finished the second stage engine test. It is getting integrated right now for the second stage vehicle, and we're going to do a vertical takeoff, vertical landing demonstration. So it's going to do a little tiny hop. And we'll demonstrate that. And so that's upcoming very soon. And we're in the middle of developing all of our stage 1 components. So that's going to be a full flow engine using methane and oxygen. And so that will, those components right now are being designed and they're being tested. We've tested the oxygen preburner, and we're working on getting the rest of those components out of the stand. So our goal is to launch in 2025, and we have met every milestone ahead of schedule. So I have high confidence that we'll be able to get there.
Now, you've recently been allocated Launch Complex 14 at Cape Canaveral. What's special about that particular site?
So that particular site is, if you go, you can see it's the Mercury 7 pad. They have that really beautiful monument out front that you can go and you can visit and you can take a look at. It's the historic pad for John Glenn. So we're just incredibly, incredibly honored to be allocated that pad, and we'll take care of it.
What needs to be done to prepare it for launches for Stoke Space?
So I don't know if you've ever been to the Cape and kind of driven around there. You have, right? And so you can see all of the different launch complexes that were essentially just left. And, it's a little bit sad because you look back and you see all of them there and how active we were in space at one point in time, and how busy that area was for launching rockets and other activities. And so when you drive through there, it's a little bit sad that, so much of it has been abandoned. So that our particular site, except for the monument and the blockhouse, which has been updated and cared for, but the large structures, the ramps, and some other features have been just essentially abandoned and left to the elements. So we need to go through, we need to do environmental assessment to make sure that we're not going to hurt any of the native species there. Then we also need to go through and make sure that we're preserving what we need to make sure that we take care of the past. And then we need to look at our designs and make sure that what we have in place there can support our operations and our launches. So there's quite a bit of work that actually needs to be done there, but we need to do a little bit of assessment to understand exactly what. And I would say we're really looking to try to maintain as much of the historical, I would say, look that it had before. So we're trying to do that, and we're looking into how best to do it.
Well, I live on the coast of Florida,
Oh, there you go.
a little bit north of Cape Canaveral, but I was down there for a recent launch, and when you live and work this near the ocean, it's a harsh environment. Not just metal, but concrete even begins to deteriorate after a while in the solitaire. So I imagine that's been sitting there unused for that many years. There's going to be a lot of just real solid infrastructure work that needs to be done to bring it back up to spec.
You're 100% correct. Yes, absolutely.
Now, Elon Musk says he builds the machines to build the machines. Stoke Space has written the software to design, make, and manage the machines. Tell us about Fusion.
Tell you about Fusion. So Fusion is an inventory tracking software that allows you to create workflows and take a part that you've designed. You've taken the drawing and you can integrate it with that software that controls the drawing. And then you can essentially create the product itself in Fusion with the appropriate components. Then you can track the data for each of those components. So let's say you were designing a shovel and you had a drawing for a shovel, and you loaded that drawing into Fusion, you created an object for that. Every one of those pieces of that shovel could essentially then be tracked in there with serial numbers and test data and workflows that describe the process to make the shovel, and really everything that it takes in order to bring the piece of hardware from a drawing all the way through production, or all the way through R&D and then production, and keep track of it until it emerges as a finished product. And so this is something that didn't quite exist in this form and wasn't useful in the sense of going from R&D to production. And we didn't have something as we were approaching this problem, and we looked externally for some type of software that would do this. And we've had quite a bit of interest from folks in utilizing the software. So this didn't exist before, and we developed it as we were building the rocket. So we had engineers give feedback on the product, help us improve it. And so it's a software that has helped us be successful and that we've utilized. And now we're offering it to others.
So how critical is it then to manage that design, build, make process? The companies have actually been doing that for a long time, but how difficult is it to get the system dialed in?
Let's see. It's not that difficult when you have Fusion. Sorry, that was a shameless plug.
That's why we're here.
It is not difficult. I would say in the past, a lot of companies will use bombs that are Excel based, and a lot of times they'll other types of programs that use or create bombs are so controlled, it makes it very, very difficult to edit or to really utilize them for R&D. And so Fusion focuses on being able to use it for R&D, to be able to kind of optimize your bomb and change your bomb as you need to, but at the same point in time, move on to production once you have that locked down. So how hard is it? It can be very, very difficult, especially as they start to grow, and as you are trying to essentially take the philosophy which we have, which is, design, test, iterate, design, test, iterate.
What's the long-term vision for Stoke Space? Where do you see the company in, say, 10 years? What do you think you will have accomplished?
What do we think? I think that we are going to, this is my dream. And so this is my vision that you have here. I hope that we have rockets flying daily out of Vandenberg and the Cape and maybe another site. And we are essentially, you can go to our website and you can just book a ride. So, you can say like an airline ticket. And so we're essentially, we're selling tickets to space, not rockets or launches. We're selling tickets to space. And it's run very similar to how you would see an airline, an air travel. And it completely runs like that. And we're operating just like that.
And of course, you don't have to build a new airplane every time you want to go fly.
You do not, no. And the site, you don't have to spend days inspecting between each flight, right? It goes on the ground, it gets turned over in a couple of hours, and then you're back up in the air with it. Yep.
So where do you see the demand then? Do you think there's enough demand for a company to launch something into space every day?
Yes, I do. I absolutely do. I think that demand will only grow. I think we are seeing the emergence of a large space economy, just with Earth observation and improvements in Earth observation for weather monitoring, or improvements in agriculture, for missile warning, more on the defense side, or even for just overall resource management, for pollutant monitoring and policing. All these things will only grow, and we'll have more and more data to help us, effectively live our lives. And and that's only one tiny component. Then you have the communications industry. You see large mega constellations emerging for those, and that will only continue. And then you start seeing resource utilization in space. So asteroid mining, and even economies that utilize lunar technologies. And so I think I think it will start, in near Earth orbits, and then it's just going to keep growing and growing and expanding. And launch is all key to that.
What's your niche? I mean, you talk about medium lift rockets, you talk about heavy lift rockets. What's the niche for Stoke Space?
So we're medium, and we'll grow larger. So our first block will be medium, and we'll just keep expanding until basically the market tells us to stop.
Is it something that it's harder to build something bigger to become a heavy lift company, or do you think you'll just be able to take what you have and scale it up?
Oh, I think we'll be able to take what we have and scale it up. I would say the difficulty doesn't necessarily become launch or design itself. It becomes, how do you get it from your manufacturing location to your launch location? And so it's a lot easier for companies to start off smaller, just because of the logistics in transport.
To that point, you're on the West Coast, and your launch site is all the way over here on the East Coast.
Yes.
Are you planning to expand into Florida, where you'll be much closer to where you're going to be doing at least your initial launches?
I think we're going to expand everywhere. So,
Good point.
So yes, at some point in time, I definitely see us moving into Florida and having manufacturing facilities there as well.
You'll love the winters here, I promise.
I'm sure they're much better than Seattle.
Well, I've never spent a winter in Seattle, but and the one time I was in Seattle, and it's been many years ago, it was nice and sunshiny and the weather was beautiful. And I mentioned that to somebody on the pier, and he turned to me and said, "Don't tell anybody."
So I have to tell you, before I moved out here, all the times I visited, it was beautiful. It was exactly warm and sunny and phenomenal. It's not always like that, I do have to say.
Well, we get an occasional hurricane here in Florida too, so every place has its downside. We're just about out of time, Kelly, and it's been delightful chatting with you, but we ask all of our guests this question, and I want you to look out over the next 10 to 15 years in space commerce and the role of Stoke Space, and tell me what you see.
I see Stoke Space allowing a large number of new companies and startups to really flourish. They need launch, and they need to be able to get into space. And I think Stoke Space will enable that. And I think it's very difficult to ride share on SpaceX and then Starship. And so I think that people are really going to look for a smaller rocket that can take them to exactly where they need to go quickly, at a low cost. And I think people are going to look to the sustainability aspect as well, and enjoy knowing that their ride, to orbit is done with the most, climate-friendly technologies.
Is the lack of launch capacity a logjam right now? Is it a choke point, or is the demand right now pretty much where it needs to be? Or are there companies just lined up waiting for a ride to space?
There's companies lined up waiting for a ride to space, I would say, and I believe it's gonna become more and more of a choke point.
Well, Kelly, it's been great chatting with you. Thank you so much for joining me today, and good luck. And maybe I'll come out to the West Coast and come have a look at what you're doing, or we'll catch up at some point when you're down here at the Cape.
Oh, awesome. I look forward to that.
Super. Kelly Henning is COO of Stoke Space. Thank you very much.
Thank you. Take care.
That is going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Google Podcasts, Audible, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss an episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at Ex Terra JSC. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers. My Galileo through is looking glass. That's for reason. A dreamer's eyes we gaze into a sense of purpose, know my view. Like finding water on the